Hello everyone. How to calculate and draw shear forces and bending moment diagrams. Shear forces and bending moment diagrams. So follow me in this video to know. Please subscribe to the channel to reach every important video upload and share the video with others if you like it and ask any questions and I will reply you as soon as possible. Let's go now. To understand shear force and bending moment diagram, this link is very important. It's in efficientengineers.com. So together here we will learn together how to draw and calculate forces around point and the bending diagram in the beam or the forces, shear forces in the beam, shear forces in the vertical forces and the moment, bending moment for this beam. This is the bending moment. What are shear forces and bending moments? So to know the forces, we have two essential forces: shear forces and normal forces. Shear forces, which is uh, vertical direction, parallel to the beam cross section. This is I beam, and when take this cross section, this forces is the vertical on this beam and parallel to the cross section, while normal forces that are oriented along the axis of the beam. So this it's perpendicular to the beam cross section and oriented along the x of the beam or parallel to the x of the beam and perpendicular to the cross section of the beam, as this diagram showing you. So we have here the force may be compression or tension. This is the compression in the red color, compression, while tension in the blue color, tension. Okay, tension and compression forces. There, here with the bending, this is the shear forces and the bending. Try to bend the beam. We have counterclockwise beam, center clockwise beam, and anti center clockwise or anti counterclockwise bending. So this is the concentrated force, and this is a distributed force, and here concentrated moment. Try to rotate this beam around this joint or this point, and here we have different type of support. This bend support, so there is no vertical displacement, no horizontal displacement, but there can be rotation. It can rotate about this point. And this ruler support and no vertical displacement, but it allow horizontal displacement and can rotate. This is fixed support, the no moment, no rotation, no vertical displacement, and no horizontal displacement. Here we have a beam and there's two supporters. One allow only rotation and the other allow rotation and horizontal movement. But we have here two types of loading. One concentrated load, uh, 36 kilonewton, another one distributed load. Okay, so here uh, these horizontal and vertical displacement are not allowed, and here vertical displacement is not allowed. And you test this, you can write here or calculate the bending about this point. So we calculate the summation of the moment. So we have one moment about this 10 kilonewton times this 10 meters, we have 100, and we have uh, in the other rotation, or this clockwise, this anti-clockwise, we have 10 by 5, we have 50 kilonewton. So we have here the summation, or the result will be total moment will be minus 50 kilonewton by meter. And this is explanation how to draw free diagram, body free diagram. In the body free diagram, we have three equations. The summations of forces in the x direction is 0. The summation of y forces in is 0, and the summation of moments in this around this point on the beam is 0. So we can take example and calculate this. Uh, we take the rotation or the moment about this point, and the vertical forces and the horizontal forces, and all equal 0, and find the missing uh, uh, or try to calculate what needed, and then move to the right and the next point, and after the point we calculate also the three things, the vertical and the moment. The vertical, we concentrate here with the vertical, not the which is the shear forces, and the moment, or the bending moment. And then in the third point we go here and repeat, calculated the vertical force or shear forces and the bending moment, and until we reach at uh, uh, the other end, and then we complete this. So this is a bending. If this rotation like this one, we have here the force up in the left and on the right down, so the rotation will be anti-clockwise. If the we reverse the direction of forces, so we have the rotation will be like this in the left, uh, with clockwise, and in the right anti-clockwise. Okay, so the rotation here, the result will be in the direction of the more force about the point. So it depends on the distance, for the distance of the point, and the value of the force. Example here. Here we have an example. This example is good example. We have two supports. One not allow horizontal or nor vertical forces displacement, and the other not allow only the vertical displacement. So we have this point A and this is point P, and we have this loads, two types of concentrated loads. One is 15 kilonewton after 2 meter displacement from the left support, and after 2 meters we have another load. It's lower than this one. It's only 6 kilonewton, and we will calculate now the shear forces on the uh, point A. So the summation of Fy is equal 0. So Rp plus Ra, because they are supports upwards, equals 15 plus 6. And then we have the total or summation of momentum about B. We start with the P point on the left side. We have uh, the we will calculate here 6 by 2, then 15 kilonewton by 5, and then we have RA minus RA by 6. Okay, 15. Then we calculate RB, and we find RB, and then we can calculate RA. Here we have example, another example. And now how to draw the shear forces and bending moment. We start with the first point, this one. So we have here 12 kilonewton. We up by 12 and draw horizontal line until we reach the second point. And here the moment about this point will be 12 by 2, so we have moment about of 24. So the moment here increasing, though the moment is increasing because here the force is 12 times 1, it's here 12, and here 12 times 1.5, and here 12 times 2, so we have this slope, uh, because 12 times x is 2 here. Okay, then we calculate, we setting here after this point and calculate. So we have the total force here, it's up 12 and down 15, so we are going down 3 kilonewton. So in the second diagram we will show you, we will go down 3 from the 0, and here we will calculate the bending about here. So here we have this bending and this bending. Okay, so the bending will go down because this is slope. So we calculate here at this point 3 kilometer, 3 kilonewton until here. So we will calculate the bending here. So we have 15 times 2, 30. Okay, and uh, uh, 12 times 4, it's about 30, 48. So we will decrease here to 18, 18, and the slope will, the difference between this point and this point. And then we calculate here, we will setting here the, after the point, and we have more 6 kilonewton down, so this will be minus 9 here, down minus 9, and go horizontally here, and the third showing you, okay. And if we calculate the moment around this point, it will be 0, so the slope will go down to 0 because this is the end of the beam. Very easy. If there is any question, ask and I will reply you as soon as possible. Um, don't forget to subscribe to the channel to reach every important video upload. Thanks for watching.